Hello, welcome. My name is Veldboom, and in this video, I'll be showing you guys how I make my suspension wishbones and the whole geometry and everything for the 2004 Vision car that I have. So I've already made the lower wishbone, and in this video, I will also be only making one wishbone. And because the process is just basically repeat and copy towards all the other wishbones that are there, so it's not like necessary for me to do everything. Right now my SolidWorks is loading up, but I can also like talk you guys a little bit through a couple of renders that I already made of the lower wishbone. So in these renders you'll be able to see that the wishbone is actually coming through the wheel, so you will be able to see the whole wishbone assembly from outside of the car, and usually that is all obstructed by either like a brake disc and a caliper or other like suspension wishbone spokes or not suspension wishbones, I should say like actual rim spokes. So right now that whole design is open, so you can basically see everything from all the angles and everything, and you'll be even be able to see that when the car body panels are attached. So that is something that I'm very much looking forward to. And also, before the file loads up, please subscribe to this YouTube channel. If I get to 1,000 subscribers, then I will actually be able to monetize a couple of my videos, and that would help out during the quarantine time. So yeah, if you're able to, please subscribe, and also if you enjoy this content. So hopefully now by this time my SolidWorks is already also loaded up, and a couple of you guys have subscribed, and then I will be able to take you guys through the process of making another wishbone, but it's taking a while. So right now you can also see that I kind of made a carbon fiber monocoque for the car, and I haven't really put that in video form because I didn't really have the time to do that, but I will kind of make another video explaining on how I did it and what the thinking process behind it is and all of that, so don't worry about it. But for now, I will just show you like the lower wishbone and how I made everything and designed it, and what the principle behind it is gonna be, and then I will then continue on making the top half. So for the lower one, you can see that I kind of made an encasing for, or like a bridge kind of setup to house the ball joint that will actually be attached to the wishbone, because with this ball joint you have the ability to not only have suspension going up or down, but you can also let the wheel rotate. So for steering you would need that. If it would be like a regular suspension, yeah, like a joint here, then it would only have the ability to go up and down, and you wouldn't really have any steering capability. So that is why we use ball joints here. And if I go to this part separately, then you'll be able to see how this is made, and it's very simple because it's just basically this feature tree, and I could have even made it in just 2 steps or just one actually, because I made like a fillet, but I could have done that in a sketch. But basically what I did is I made one rod, and then I attached like a sketch to that rod in the center of it, and that was of this circle. And then I made a revolve around the center line of the rod, and that is basically how I got it. And then I added a fillet, but I could have done it in just the revolve if I made the sketch like with this profile. So there's multiple ways of doing things. There's not necessarily one right or one wrong way to do it, but that is basically how you end up with a ball joint. So what I also always do when it comes to suspension is, because the geometry will not be perfect, that it is level right here, because if you want to attach the wheels in a certain way to the body, then sometimes you have to maneuver them a little bit to kind of get the angle right, and that you have still like the full range and everything, that you can do everything with it. So that is kind of why it is a little bit difficult to do these, because the angles might kind of get messed up, and that's why I'm also going to show you how to get through that. So here you already can see that I have a top ball joint in place, and also to make it a little bit easier on myself, I'm gonna take out everything that I don't need to kind of get the file size down in this model, because the only thing that I will need is actually like the stator that you can see here, and I'm also gonna take the dummies out so that you kind of get all of the RAM capable of doing it, because my computer is not that fast these days. So yeah, let me also take out the other motors that I don't really need. So here we have the smallest file size that we have, and it is also beneficial for you guys to do that if you're working on like a smaller section of the car and you don't need all the files in there. Kick them out, because the larger or the more RAM that you're using in SolidWorks, the easier it will crash too. So That is also like a tip that I have. So to begin off with how to actually make it, I'm gonna go back to the revolve, and once I have these in place and everything, I'm gonna go to show the sketch, because then I have also the center point of where the actual ball joint is sitting, and that is a very important point to have. And then you will also have to do that here to get the center point of where the axis of rotation will be for that actual mounting point. So again, let's find out which sketch that is, and then I can also, here we go, showcase that one. And then we will also have like a center of rotation for that point right there. And the next step that I always do is then I exit that component, and then for within the actual model I make a new plane. So let's see, that is here, and in assembly, reference geometry, plane, and then I select the actual center point right here of the axis of rotation for the suspension arm, and then do the same for that sketch right there. So then you have the two planes selected, but then you still need like a ground plane, and then you can select like the front plane in my case, but that is the same as this plane, so that doesn't really matter. But actually it is better to use the front plane instead of this sketch, because then it's not related to as many components, because otherwise it's going to depend on that geometry to exist there for that plane to exist. So that is a little bit messed up, but that is actually already the case with these two components, but we're just gonna keep that to a minimum for now. So that is the front plane, and then you have the same effect. Okay, so now that we have that plane, we can actually go to insert components, select the new part, and then we will base that new part on that plane, because then that will be the straight origin and everything for it. So you can see that on your cursor there's a green check, and that is this is select the surface that you want your new part to be based on, and then you have to click on the plane. So then it will kind of use that plane as the first reference to lay the ground layer for. And if you have that done, then it comes now comes the part where we start to actually model the wishbone. So that isn't too difficult. So I always like exit the sketch again, select this plane, and then because it is like an external part that is already part of something else, then you will kind of get a lot of errors and stuff like that, but you can ignore all of those. And select the inner circle, click on convert entities, and I think I used like a 20 millimeter outline or something, or like an outer radius for that circle, and then it is again like I think it was 40 millimeters. And then you have the first circle to have like an attachment point for your actual wishbone. So do the same thing on the other end where the suspension frame mount is. And of course I didn't show you how to make these, but it is like very rudimentary, like very simple. You don't even have to make it as a separate component if you don't want to, if you have like a chassis or something that already has like a hole in it. So once you've selected this second phase, I'm gonna go back to that new part that we just made, and then I can copy the sketch that we used on this previous lobe. So you can just click on that sketch and click on convert entities, and then it will appear right there, same thing all over again. So you can just again do like a boss extrude to then also have it for 40 millimeters. And I'm kind of talking through it because my SolidWorks is constantly lagging. So I really need to upgrade my computer. This is getting very annoying. Every single time, like it's lagging once I push a button. So I'm going through great lengths to make this video, because if I'm not screen recording, then it's not this bad. So yeah. But at least now we have the second lobe, and then we kind of need to make one third one, and that is for the ball joint. And once we have done that, then it's kind of easy sailing, because you can exit this assembly, and it's a little bit easier to modify things from outside that assembly. Also, what I'm gonna do is I'm gonna modify the carbon fiber to be like a regular texture, because I also feel like, because it is like a graphic thing, like just see the pattern constantly, that it will probably also like slow the computer up a little bit. So I'm gonna just keep it like this for modeling purposes instead of showing like the graphics and everything with the carbon fiber. So those are also like a little bit tips and tricks to keep it smooth and to keep also like your file sizes down and everything. So yeah, I will again select that plane 2 that I made, and before I do that I kind of need to be in the new part. So then select the plane 2, click on sketch, and what you can do then is go to the ball joint if my computer allows me to, and I will be able to find that line, and that is the line that is sitting exactly on that sketch plane. So then you can just click convert entities and select offset entities, and did I do it 10 millimeters? And then because the inner one was 15 millimeter radius, right? Yes. So I'm gonna extrude it for 30, and then select, instead of blind, select the mid plane. So it's using that as the middle reference point, and then it's going in both directions. So now we actually have the point where the suspension, the ball joint will sit, and we have where it is mounted to the actual monocoque of the car. So what I can do now is go to the part itself, and I'm gonna save it real quick. And now that we actually have, like, I call it the front upper wishbone, because it is I'm designing it for the purpose of actually being able to flip it over to the other side and to not have like separate components for front left and front right, but just have a front component so you can multiply it. In production it will save you time and money, because you can just order 10 of something for 5 cars instead of adding 10 for 10 cars. So because you would have to have separate sets, things of that nature. So to have, like, if you can multiply, if you can use the same component on the left side to the right side, it's always beneficial. So that is kind of why I did that. And I also heard, like, in a previous video, that I shouldn't really stomp on the table like that. So again, but now you can kind of see why I made the decision to make the new part on the plane, because now if I go to the front plane, it is actually completely centered, and it is perfectly within these lines and on the basis of everything, and it's not at an angle anywhere. So it is just straight all the way, and you can, like, it is, yeah, it's perfect. Because otherwise, if I wouldn't do that, then you would see that it would actually sit at this angle, and then would make it awkward to mirror it along to the next side and everything. So that is kind of why I did that. So hopefully that is understandable. So now that we're actually in the front upper wishbone, I'm also make like a top and bottom section for it. So right here I can select the boss extrude and select the convert entities, and add like 10. Yeah, it doesn't really matter because I'm gonna cut it off anyway. So add like 10 millimeters to the top and the bottom section for it, and yeah, do that on both sides. And then I'm gonna use the, what is this called actually? Section view. So I'm gonna take it from a side angle. Let's see, where is it? Actually right down the middle of that thing right there. And then I'm gonna select the fillet tool, and because this is now a cylinder that is exactly like it has a 15 millimeter radius and it is 13 millimeters high, I can just select 15 and it is a perfect ball right there. So there we go. So that is already like the attachment for the ball joint and everything. So what we're gonna do now is again go to the top surface and do a cut extrude, convert entities, and select I think 15. Yeah, 15 should be good. And then again do the same thing from the bottom, 15. And if you now exit the split section view, we can see that we have like a little bit of a comb shape on the inside of it, with that a ball joint would fit in. So what I also do is I add a little of a fillet, but not too big, so maybe like a 2 millimeter fillet or something to kind of open that hole up for the wishbone, for the ball joint I should say. And then I'm gonna select again the plane, so that would be this plane, because from here on I can then just do like the mid plane again. So that's very similar to the initial process. So again, I'm gonna select the straight top view, and then I can draw like little squares here. that are the exact same width as the ball joints themselves. So I can just select that and drag it out a little bit, but I don't really want the distance to be too big, so let's put it at like 5 millimeters of an edge, and then I'm gonna just copy this section to here, and then I'm gonna do the same for the actual ball joint section of the wishbone. So again, have it like perfectly closed off, and then this length is supposed to be 50, and then if that is 50, then I'm gonna put this at like 25 to kind of close that off perfectly. And then what I'm gonna do is I'm gonna add some splines. So from here to here, we'll have one spline, we'll have another one from here to here, and then there will be one in the bottom. So I'm gonna make that, the one at the bottom is interesting because for this upper wishbone, because the way that I'm gonna make the suspension with like an electric motor that is attached to this wishbone with a push rod, or a pull rod I should say actually, the electric motor will then control like the ride height of the car, and also like its rolling and bump adjustments and all of that. So that is like a technology that Audi came up with. So I would need to make a point in this wishbone for, again, like for like that pull rod to be connected to. So yeah, I need to figure out what and how I'm gonna do that, but it's not too difficult. I can do that once I kind of make the standard shape of the wishbone. But you just need to be like a little bit preemptive with your thinking before you make something, you know, because it can save you a lot of time for sure if you just have like a vision already instead of just going off your gut, which I do too often. But I'll show you guys what I'm talking about with the motor and everything once this is finalized. So yeah, with this point right here, once you selected it, you will kind of get like the line properties and everything for the spline right there. But if you then hold down your control button and also select this line, damn. So with the spline tools and everything, you can basically click on this point for that control pylon, and then also click control and select this line right here, and then select I can never pronounce that word, collinearly or something like that, but at least select that one, and it will just follow that guideline and make it that this point is kind of matching perfectly to that point too. So do the same here. So just select that point, hold down the control button, and select again that word that I can pronounce, and repeat the process. And this just ensures that you have perfect lines with that match with each other perfectly without any type of gap or anything between them. And regularly you would be able to do that with like a fillet tool, but this will just save you that that movement. And if you then want to adjust them, you can still like, there, I messed that up. And if you want to adjust them, you can still like pull on them, and they will kind of stay in that shape, and then you can adjust it however you want to. And even what you could also do from this point, if you still don't like it, is right click it and then add like a tendency control to the middle of the spline, and then you can adjust it even further. So it just depends on what you're looking for and how you want it. But for me, this is already fine. But I just thought that maybe that is something that is helpful in the future to some of you guys. So again, with this spline, I should talk more while I'm doing this stuff. So I should describe what I'm doing more. So again, I use the spline tool, and I've dragged like one point right here in the middle, somewhere in the center of it, and then again attach it there. Do the same thing once more to have like this the control pylon, and then again select that word that I can pronounce, and yes, there we go. And then with this control pylon, kind of do the same thing. What was that? Okay. And then yeah, is this a good point to figure out what I'm gonna do with that suspension mounting and everything? Like, I think I'm gonna do something like directly in the center of that point, because it will be visible in the car, and there also isn't like what should I say, like a output shaft from an electric motor on the internals of the car, something that is going towards the center, so that the whole center section will be open for me to do whatever I want to do with it. So I think I'm just gonna use that section, but let me just finish this and then I'll talk a little bit more about it. So yeah, the next step is to then basically do like an extrude. So again, select the mid plane, and I'm gonna put this at 20 millimeters, maybe even 25. But then this is no longer gonna match. So yeah, I'm gonna just put it at 20. And then I can select this surface and do an extrude, but that is dumb. I'm gonna keep my mistakes a little bit in the edit, so you guys can also see what my mistakes are. But I can already like also within the sketch, I can select this outer circle, convert entities, and then just do it in one go. You want to keep your amount of features that you use in a file just as down as much as you can, because all of those will add MBs to the file size, use up extra RAM and all of that. So everything that you can keep as small as possible is beneficial to your overall performance and everything. So yeah, and then these lobes still need to be attached. So select the surface, click on convert entities, and then do another extrude, and then you can just double click that surface, and because the surface here is the same as there, you can just attach it directly. And now we have our wishbone setup. So for the next part, let's see, this is not really attached properly. Okay, so those aren't merged together. Here, merge results, and then select all bodies. And then now you can see it's one entire part. So then I can select damn, I really want to make that attachment point right here. So I'm gonna use it. Does it need to be a ball joint in there, or is it even possible to do it with just a regular joint? I think it will be. So I'm gonna use a cut extrude, and from the center of this line right here, I'm gonna do it a little bit more towards the right. So let's say that is like a 10 millimeter offset. And then from that point, I'm gonna use damn, how large should it be? I think the hole itself will be good if it is like 5 millimeters or something in its radius. And then yeah, I'm gonna just start off with 5. So I'm gonna cut this all the way, but in both directions, so through both directions. And I'm gonna then again select the surface, again do a cut extrude, and again select the circle, click on convert entities, offset entities, because now I want to make a bigger circle out of it. And instead of doing, let's do 5, but then it's sitting perfectly on those edges, so that would create another 0 thickness geometry and everything. Okay, so I'm gonna not do that sketch right now, but we'll save it though. So we already have that hole in there, and now I'm gonna make a bigger hole. So I selected the top surface, clicked on sketch, and then I can probably do convert entities right here, or I can't. Okay, so now that I have the hole here in place where like this, the axis of rotation will be for the ball joint. And two, one thing that I should also mention is that I move this rotation point as far forward as possible, because the moment arm of like the actual pushrod being attached to that wishbone is supposed to be as long as possible. The longer it is, the better control you will have over that motor and controlling that ride height and all the forces that will be put through it in the suspension and everything. So that is something that you should always do, is kind of maximize the length of these moment arms in the suspension and everything. So that is why I put it up to this position. But now I need to make like a hole that is actually like a bolt able to go through it. So I'm gonna select the top surface and select cut extrude, and then from this point right here, I made like a 10 millimeter offset for a 5 millimeter circle radius. So if I make like a box here that is 10 millimeters, off, then this will be like the same center line of everything right here. So I can then kind of do offset entities, don't select chain, bidirectional in both directions. So, and then I'm gonna make it 15 millimeters in both directions. So then I can kind of delete this line right here. I won't need those. And then from the top view, or I should just do the normal view too, I can then kind of drag from the center of this circle right here and draw another line, and also do like 15 millimeters. So then I will have like a 3 centimeter cube section right there that I can cut extrude. So I'm gonna trim all of these entities that I'm not gonna use out of that section right there. And sometimes it's good to keep them in there just to have the relations that it can move, but you can also just fix these sketches if you're kind of used to having like undetermined or determined sketches or something, so you can then make them fix, and then they will go black and they won't ever adjust in their dimensions. So that is also something that you can do. I usually don't, but I should though. But yeah. So again, you would have that, and then I'm gonna add like a nice fillet to it. I don't know how big I can make it. I think it will be pretty nice if it is just perfectly rounded off. So because it's like a 20 millimeter height, then you can put the fillet at 10, and then we'll kind of make it a perfect circle right there. And yeah, it has like a flat surface, but it is kind of because this is in there. But I'm gonna do the same on the other side. And then from here, I need to make something that there's actually like a possibility for a bolt to be bolted through here. So what I'm gonna do is I'm gonna again select this surface, and for this radius right there, I'm gonna make it at like 12.5. So it is gonna be like a little bit extruding outward of everything, but that will be fine. So yeah. And from here, I'm gonna just extrude this, but it should also have the hole in it. So convert entities on that sketch to keep the hole there, and I'm gonna just extrude it up to this point. And even though it's like fully up to the edge, that's not too big of a problem. But if you do want it, because it probably will look nicer, then you can still kind of select all of those entities and just do like an extrude up to surface, and then you can select that surface and it will be fine. So then you have like a nice rounded off edge. Repeat the process on the other side, or maybe like let me finish off one more thing before I do that. So then again select this surface again from the sketch, but now make it like a 10 millimeter hole in radius, and then I'm gonna use the offset, and I'm gonna drag it, let's see, inward, and then I'm gonna reverse this, but it shouldn't be 10, then it should be like 7.5, something like that. And then you actually have like a spacer for the bolt to sit in there, and then I'm gonna repeat it to the other side right now. So yeah. So now we have the two sides where we actually also have the hole in here. So now we can like put like a bolt in here, attach a pivot point, and then you will be able to like push that rotational bar in there. But I actually think that for the spacing, we kind of need to push this point a little bit forward. So what I'm gonna do is I'm gonna kind of put that kind of roll that feature tree a little bit up, and I'm gonna do another cut extrude here to kind of give it a little bit more space to actually bounce in there, because that rod will actually go in this direction, so we need to give it a little bit more clearance there. So that will be fine. That is probably even a little bit too extreme, so but you know what, let's keep it like that. And then I don't know if the fillet will automatically also change with it. No, it didn't. So then we need to adjust that fillet too, and kind of select these edges as the ones that it's missing right now, and it will then replace those. So now here we have like a little bit of a more sophisticated looking engineering type yeah, wishbone I should say. So now I'm gonna just do everything to make it look nicer. So I'm gonna add some fillets here. Is that the right way of pronouncing that? Fillets? I don't know. And kind of mirror that along to the other side. maybe I shouldn't do the fillets right now. Let's first do like the extrude itself. So again, select the top surface, do cut extrude, offset entities, and then reverse them. So let's put it at like 5 millimeters, or maybe do 7.5. And then we kind of come up with a surface like that, and then we can cut extrude it. And because it is actually 20 millimeters thick, I'm gonna put it again at 7.5, because then I can also do that on the bottom section to keep it like all the same everywhere. And now that I think about it, before I do the cut extrude, let's add a fillet to this section here. Let's make that 15 millimeters to kind of round everything off, and then do the cut extrude. And then you can see it automatically also adjusts because you use the offset entities and everything, so it will just go off of the face that is sitting right there. So to kind of add a little bit of strength, I'm also make like a little bit of like a rod here, like a rib I should say, and do that like a directional offset entities. I don't know if 7.5 is a little bit too much, but at least like we'll have something in there to add like a little bit of strength to it. And then other direction. Cool. So the next step will be to add more fillets to the inner shapes to kind of round things off a little bit nicer. I should put this at like 10 millimeters I think, or no, let's just do 15, and then we'll. So now that we have like the top surface of everything, before we actually add the fillets to the outer rings and outer surface, we can go to the bottom, select select the bottom surface, click on sketch, and then select the convert entities, and then select both of these surfaces, and then you'll be able to see those on the bottom section. Cut extrude both of them. Why? For some reason this doesn't seem to work. No clue why, but something is wrong, is weird is happening with the sketch somewhere, that it kind of keeps it open for some reason. But what I can do, which isn't the best solution but it is possible, is to then cut it in half straight through and then mirror it onto the next side. But before I do that, then if I use that method, then I'm gonna just finish this whole top section and then get and then mirror it in one way instead of kind of doing it all over again on the bottom section. So I'm gonna then kind of use all of these fillets and everything, make everything as smooth as possible, because that will also help with the strength. It does also add a little bit of weight, because this is all the material you're also adding right here. So I'm gonna use the same here. Select which plane is it? The front plane right here. Select extrude cut, make like one big rectangular shape that kind of follows everything, and then you'll see that it is perfectly down the middle. And then I can cut extrude it downward, and then I select the mirror tool, grab this surface, bodies to mirror that whole thing, and then boom, perfect. So there we go, that is the front upper wishbone. So if I now go back to the assembly, I'm gonna close this off because I fear that my assembly is gonna keep like you know, cause everything to slow down a little bit. So now you can see that we have the two wishbones, actually one in the top, one on the bottom, and this wishbone will automatically be able to be put right here in this section. I still need to mirror this side, and I also have the suspension mounting points from the monocoque here on the other side, and my SolidWorks again clogged up. But then you will have the push rod actually being attached right here to the wishbone, and that is also like going downward into the actual electric motor that will control the actual ride height. So that will allow the car to have no anti-roll bar, because all of the rolling resistance and everything will be controlled via the electric motors. That will allow the car not to have any type of springs at all, and because these are like usually like thick steel coils, they are also very heavy components that are usually mounted higher up in the car, everything. So it just has a lot of benefits, keeping also the car very simple. It's based more on electronics than on mechanical components for sure, but with reliability, the less parts you have, the less parts can go wrong. So that is kind of the whole thinking of this 2040 design project and where I want to take it. Um, it's also looking amazing. That is my highlight personally. So I'm again make the renders like I did with the previous one, that you can see the top and bottom section, and this is coming along very nicely. Can you imagine like looking at the suspension wishbones from outside? We have never seen this before on a car. So I'm just satisfying myself with doing groundbreaking shit right here. So I'm a little bit overexcited, my bad. Yeah, thank you for watching. Please leave a like, also subscribe to this YouTube channel. If you enjoy this content, make sure to really subscribe, because I'm gonna be uploading these type of videos more commonly and more commonly when everything is starting to take shape. And also maybe like some short films and animations and everything. I'm learning how Cinema 4D works, so I'm probably will be able to do like a lot of cool stuff with that too. So yet again, like I said, thanks for watching. Please leave a like or subscribe to this YouTube channel. My name is Shaquille Veldboom. I'm out.